and we're going to start chapter 5, and we're going to do section 5.3. 5.1 and 5.2, I don't know why, but they're in MAT 102, so we skipped those first couple of chapters. So this is rational numbers, which is fractions, which is always everybody's favorite. Okay, so rational numbers, a set of rational numbers are denoted by Q, is a set of all numbers in the form of, you can write it as P over Q, where P and Q are integers, and Q is not equal to 0. You can never have a 0 in the bottom of your fraction. So all of these are considered rational numbers. Even 2 is considered a rational number because really you could write it over 1, and the same thing with 0. You could write over 1. You never write a 0 on the bottom of a fraction. That's considered undefined. So fractions are numbers such as 1 over 3 and 7 over 8. The top number is called the numerator, and the bottom number, down, is called the denominator. It's a good way to remember it. So reducing fractions, to reduce a fraction to its lowest terms, you divide both the numerator and the denominator by the greatest common divisor. So if I'm going to reduce 54 over 90, divide them both by 18, and you're going to get 3 over 5. Now, technically, if you looked at 54 over 90, and you said, oh, well, I know 9 goes into both of those, and you said, okay, so this would be 6 over 10, then you could do it again and say, oh, well, 2 goes into both of them, and do it 3 over 5. So technically, you don't have to do the largest one, but you do have to go until you can't reduce anymore. So up here, I divided each of them by 9, and then I divided each of them by 2, okay, until you get the lowest fraction in lowest terms. It can't be reduced anymore. So another example is, like, let's say I had 8 over 10, and I'm going to divide them both by 2. I'm going to divide this by 2, and I'm going to divide this by 2. So I'm going to get 4 over 5 would be my answer. For some reason, like if I have a number like 12 over 24, dividing them both by 12, I get 1 over 2. I don't know why. For some reason, students have trouble with when I have 24 over 12, that's 2. It's not 1/2 because the larger number's on top. Because, again, if I divide them both by 12, I'd get 2 over 1, which is 2. So be careful that you don't all of a sudden, and I don't know why students do that, but they do, they flip the number around. Okay, so a mixed number consists of an integer and a fraction. So 2 and 3/4 is read as 2 and 3/4, and it means 2 and 3/4. So an improper fraction, a rational number is greater than 1 or less than -1 that are not integers. To say proper fractions, improper, yeah, may be written as mixed numbers or an improper fraction. An improper fraction is the fraction where the denominator is larger than the numerator. That's considered an improper fraction. A lot of times it'll say not to leave your answer like that. So if it doesn't say, you can leave your answer as an improper fraction. If it says in lowest terms, then you should always change it to a mixed number. So if you want to change a mixed number to an improper fraction, you multiply the denominator of the fraction in the mixed number by the integer preceding it, add the product obtained in step 1 to the numerator. The sum is the numerator, the denominator stays the same. That's a summary. You could read it. But so what you do here is you take 5 and 2 and you multiply it and add 3. So 5 times 2 is 10, adding 3, changing it to an improper fraction is 13 over 5. So here would be 4 times 8 is 32 plus 7 is 39. So that's how you're changing it to an improper fraction. And it doesn't matter if it's negative, okay? So the same thing happens. So like if I had -5 and 1/3, when I multiply here, I get -5. I'm just going to do 5 times 3 is 15, plus 1 is 16 over 3, and I'm just going to make it negative, okay? Just make sure that the negative goes with it. So if I did 10, and the negative would always be here, 2/5, this would be 10 times 5 is 50, plus 2 is 52 over 5, but it's negative. So make sure this number, the denominator, doesn't change. And then just simply 1 3/7 would be 7 times 1 is 7, plus 3 is 10, So that's how you would change to an improper fraction. So now if you're going to do the other way, you're going to change that improper fraction to a mixed number. You divide, and then the new fraction has the remainder as its numerator. So if I was going to change 8 over 5, I would divide 5 into 8. It goes once, and the remainder is 3. Here's our remainder again. Remember we did that last chapter. So it would be 1 3/5. Another one, 225 divided by 8. It goes in 28 times with a remainder of 1. So it's going to be 28 1/8. So again, if I was going to do a negative, it would be, let's say I had negative 13 over 5. I'm just going to do 5 into 13, just ignoring the negative for a minute. This goes in twice with a remainder of 3. So I'm going to do 2 3/5, and it's just going to be negative. And let's say I did negative 47 over 6. So 6 goes into 47 7 times with a remainder of 5. So this would be negative 7 5/6. Okay, so you're just going to divide. You always divide the denominator into the numerator. Okay, that's the biggest mistake that students make. Okay, so a decimal can be terminating or repeating. That a rational number, when expressed as a decimal, may be either terminating or repeating. So it's terminating, obviously, if it just ends. And it's repeating if you see it goes on, and then at the end, sometimes your calculator will just it'll put point, like if it was 6, it'll be 0.666, and then at the end, because it's going to round, because it ran the spaces, it'll put a 7. But still, that's considered a repeating decimal. We just put a line over the part that's repeating. So to get 0.8, what they did was they did 5 divided into 4. So when you calculate it, you're doing 4 divided by 5. And here you're doing 21 divided by 25. And here you're doing 97 divided by 40. That's how they're getting it. So you're reading this line in between as it divides 97 divided by 40. So I can show you in my calculator. So if I was going to put that in my calculator, I would do, if I wanted to know what the answer is, 97 divided by 40 is how you would put that in your calculator, and that's where they're getting the 2.47. Okay, so a repeating decimal, they put the line over the part that's repeating. So like even the 2/3. So you see in my calculator when I do it, if I do 2 divided by 3, it puts that 7 at the end, because at the end it just rounds. But really it would be represented by a 6 with a line over it. Now over here, when I do the 1 5 and 36, to get the second part, all you really have to do is do 5 divided by 36. You don't have to put the 1. Oops, and I put 2 just to confuse things. 5, there we go, 5 divided by 36. So you can see it's the 888 repeating, so only the 8 gets the line over it, and then you just put 1 point, whatever just happened there, okay? When you're going to multiply fractions, you multiply the numerators and you multiply the denominators. So this would become 3 times 7 is going to become 21 over 40. This is going to become negative 2 times negative 4 is 8 over 27. And then if it can be reduced, you're going to reduce it. So here what they did was they changed them to improper fractions first before they could multiply them. And then they changed it back to a mixed number. Okay, so that's going to be in simplest forms. So let me just do another example. Let's say I had negative 2/9 times 3 over 13. So even on the homework, if you were doing this on the homework, I want to see negative 6 over 117. I want to see that answer. And then when you reduce it, it's going to give you negative 2 over 39. So because if I just did this in my calculator, I'm going right to that. But I want to see this when you do it for your homework so that I can see that you knew how to do it. Okay, so now let's say I was doing a mixed number. So I have 1 5/7 times -3 and 1/4. So first thing I'm going to do, this is a 7, I'm going to change them to improper fractions. So 7 times 1 plus 5 is going to be 12/7 times, this would be 12, that's going to be -13/4. So then I multiply the top, I got -156/28. I changed it to a mixed number, so I got -5 and 16/28. And then finally, I reduced this. So my final answer is -5 and 4/7. So make sure, especially on the homework, that you go to the most reduced answer, okay? Make sure you don't leave it as an improper fraction, and make sure you go to the reduced answer. When you divide, you use what's called the reciprocal. So the reciprocal means that it's flipped over. So if you have 3, you flip it over to 1/3. 3/5, this is the reciprocal. 5/3. -6 is 1/6. Doesn't matter where you put the negative, but you're just flipping it over. That's what the reciprocal means, and that's what you use in dividing. So if I'm going to divide fractions, I keep the first one. You don't do anything. You change this to multiplication, and you flip this fraction over. So it becomes D/C. Then you just multiply like normal. So for the first example here, I have 3/8. So this would become a multiplication sign, and then this gets flipped over to 7/5. So my answer is 21/40, can't be reduced. For this one, -2/9, this gets flipped over, 13/3, and then I have -26/27. And again, it doesn't matter where you put the negative. Here they put it with the 26, and here they put it in the middle. Same answer. So let me do a couple there for you. So let's say I did 1 7/8 divided by 2 1/4. So first thing I would do is change it to an improper fraction. So this would become 15/8. This becomes multiplying, and this becomes 9. This is equal to 9/4, but I'm going to use the reciprocal, which is 4/9. Then I'm going to multiply. 15 times 4 is 60. 8 times 9 is 72. And then I reduce it to get 5/6. Let's say I had -2/3, 2, there we go, 2/3 divided by -4/9. So that would become -2/3. You keep the first one, and then you flip the second one, 9/4. It doesn't matter where I put the negative. So this would become 18. 2 negatives make a positive over 12. So I'm going to reduce that to 3/2, and then finally I'm going to change it to a mixed number, which is going to be 1/2. I'm going to run out of time here. This video is going to be too long, so I'm going to stop it, and then I'll continue on.